So in the last lesson, we looked at how to fill out these models, how we can figure out the number of protons, which again is looking at the atomic number of the element, the neutrons you can find by subtracting the mass number. So like for example, for chlorine, the mass number is 35. So subtracting the mass number minus the number of protons, so 35 minus 17, which gives us our number of neutrons, which is 18. And then we talked about that we assume that we have a neutral atom to begin with, so our number of protons and our number of electrons are equal to each other. So in this lesson, we're going to be talking about the electrons that are in the outer energy level. Those are going to be really important for our topic on bonding. And because they are so important, they actually have a special name. So when I talk about outer electrons, another word for outer electrons is valence electrons. And I will be using those two words interchangeably. Outer electrons, valence electrons, they mean the same thing. So if we recall, to figure out the number of outer electrons or valence electrons, we look at that last energy level that has anything in it, which for chlorine is that third energy level, and we can see that it has 7 electrons shaded in, so chlorine has 7 valence electrons. We also talked about the fact last time that you can look at the group number on the periodic table, so chlorine is in group, I go to the top, group 7A, so just by looking at that, I know that it is going to have 7 valence electrons. And that leads us to an important rule that is called the octet rule. Now, hopefully you know that the prefix octo, like octopus, octagon, the prefix octo means 8. So the octet rule is referring to 8 of something. And basically what the rule says is atoms are not stable. So we're going to say they're not happy, they're not satisfied until they have 8 valence electrons. They want to have 8 electrons in their outer energy level. There are a couple exceptions to this rule that we don't need to talk about here, but for the most part, all atoms are going to want to have 8 outer electrons. So again, if we look at chlorine right here over on the right, we can see that chlorine currently has 7 valence electrons. So in order to get 8 valence electrons and be happy and satisfy the octet rule, it's going to gain another electron. So I filled that in over on the left, and now that outer energy level, the last one that has anything in it, now you can see that it has 8 valence electrons. So we would say that chlorine has satisfied the octet rule. We will get into later how you gain or lose an electron, like where they come from and where they go. But for now, we just need to know that it will gain 1 valence electron in order to satisfy the octet rule. Now, something else that we need to look at is this is no longer going to be a neutral atom. So originally, this atom had 17 protons total and 17 electrons. That's how we originally filled in this model. But now we have gained an electron. So our number of protons didn't change, and it's never going to change. But the number of electrons since we gained one is now 18. But there's only 17 protons. So we can see now that we have more negative charge than we do positive charge. We have an extra electron compared to proton. And so the charge of this atom, instead of being neutral now, is now -1. And we'll do some more examples so that makes a little bit more sense. So let's take a look at sodium. Sodium's different now. Sodium only has 1 valence electron. Chlorine already had 7, so it was really easy for it to get 8. It just had to gain 1 more. So some atoms, instead of gaining valence electrons, instead of gaining electrons to satisfy the octet rule, they will actually lose electrons. And the basic rule that you need to remember is that atoms will never gain or lose more than 3 electrons. So in sodium's current valence shell, that last shell that has anything in it, it just has 1 electron. So in order to fill up that shell, it would need to gain 7 more. But atoms cannot gain or lose more than 3 electrons. So it has another option. Instead of gaining electrons, what it is going to do is it's going to lose that valence electron. I just removed the electron that was on the top. So you're probably thinking to yourself, but now there's no valence electrons. But that's not true. Because remember, the outer shell just means the last shell that has anything in it, which in this case is now this shell. And if you count the electrons in that shell, it has 8. So by losing 1 valence electron, sodium has now satisfied the octet rule. It now has 8 outer electrons. So just like we did last time, let's take a look at how many protons and electrons we now have. So originally sodium had 11 protons and 11 electrons, and it was neutral. But in order to satisfy the octet rule, it lost an electron. So it still has 11 protons, but now it has 10 electrons. So now we can see there's more positive than there is negative. There's 11 protons and only 10 electrons. And therefore, our charge is now positive 1. So basically, when you lose an electron, your charge becomes positive. When you gain an electron, your charge becomes negative. And that's because what we can see right here, if you gain an electron, now you have more negative charge than you do positive charge. If you lose an electron, you now have more positive charge than you do negative charge. So sodium loses an electron to satisfy the octet rule. Chlorine gains an electron to satisfy the octet rule. Now, atoms aren't always just going to lose or gain one electron. Sometimes it's going to gain or lose more. So let's take a look at aluminum. Aluminum has 3 electrons in its outer energy level. So in order to satisfy the octet rule, it either needs to gain or lose electrons. Now remember, the most you can gain or lose is 3. So if aluminum wanted to fill up the current shell that's highlighted, it would need to gain 5. It can't do that. So what it's going to have to do, it's going to have to lose 3 valence electrons. So the 3 electrons are in that outer shell, it's going to lose them. And so now, again, now its outer shell is the shell beneath that. And it has 8 valence electrons, so aluminum has satisfied the octet rule. So it lost 3 electrons. So originally, aluminum had 13 protons and 13 electrons, but it lost 3 electrons. So now it has 13 protons and only 10 electrons. So we can see there's 3 more positive protons than there are negative electrons. So the charge of it is plus 3. If we look at phosphorus, this is actually incorrect. I need to fix this. If we look at phosphorus, phosphorus in its outer energy level has 5 electrons. So it has 5 valence electrons. Again, it wants to have 8. So in this case, in order to fill up its outer shell, it would just need to gain 3 electrons. We know it can't lose the 5 that it currently has because the most you can gain or lose is 3. So phosphorus is going to gain 3 electrons. 1, 2, 3. And now its outer shell is full and it has satisfied the octet rule. It is happy. So originally it had 15 protons and 15 electrons. Now it's gained 3 electrons, so it still has 15 protons, but it has 18 electrons. So you can see that it has 3 more negative electrons than it does positive protons, so its charge is -3. So instead of drawing these big diagrams every time, as long as we understand that when, for example, when sodium lost an electron, so let's go back to where we were here, this is what we originally had. Its outer shell had 1 electron. When it lost that electron, now its outer shell was the level beneath, and it had 8 valence electrons. As long as you remember that there's levels underneath, then we can kind of take a shortcut, which leads us to what we're doing here, which is we're going to look at different elements and we're going to decide, are they going to gain electrons? Are they going to lose electrons? How many? And when they do so, what are their charges going to be? So we'll start with sodium, which is our first problem here. First, we want to know the number of valence electrons for sodium. So if you recall, to find the number of valence electrons, which just means the outer electrons, yeah, we could fill in all those circles like we did in the other assignment. But for this one, we could just find sodium on the periodic table, which is right here. We go to the top, we see it's in group 1A, so that tells us that sodium has 1 valence electron. Then I draw its Lewis dot diagram, which for the Lewis dot diagram, you're going to put the number of dots equal to the number of valence electrons. So in this case, we have 1 valence electron, so we're going to have 1 dot. Remember, that starts on the top, so 1 dot on the top. So we got to decide, what is sodium going to do? Basically, it has to either lose all the ones it currently has in its outer level, or it needs to gain enough to get it up to 8. Well, the most you can gain or lose is 3. So sodium can't gain 7. That's not allowed. What it's going to do is it's going to lose the one that it has. And if you lose a negative electron, so we say it loses 1, if you lose a negative electron, you're going to have more positive protons than negative electrons. In other words, if you lose negative charge, you become positive. So the charge of sodium is going to become positive 1. We'll take a look at sulfur. It's one we haven't seen yet. So sulfur, I find it on the periodic table. I look up, it's in group 6A, which tells me it has 6 valence electrons, or 6 outer electrons. I'm going to draw its Lewis dot diagram, so I draw its symbol, and I'm going to do 6 dots. I start on the top, I go to the right, I go to the bottom, I go to the left, that's 4, go to the top again, that's 5, go to the right, that is 6. So I got to decide, what is sodium going to do? Is it going to lose all 6 that it has, or is it going to gain 2 to get it up to 8? Well, again, the most you can gain or lose is 3, so the only option for sulfur here is that it is going to gain 2 electrons. And when you gain negative electrons, you now have more negative electrons than you do positive protons, so we have a negative charge. Our charge is -2 because there's 2 extra electrons that weren't there before, and electrons are negatively charged. We'll take a look at aluminum. Find aluminum on our periodic table. Aluminum is in the group 3A, so that tells us it has 3 valence electrons. When we draw its dot diagram, we're going to draw 2 dots, 1 on top, 2 on the right, 3 on the bottom. And then again, we need to decide what it's going to do. Is it going to lose the 3 that it has? Because it can't just lose 1 or 2. It either needs to lose all or nothing. So is it going to lose the 3 that it has, or is it going to gain 5 to get up to 8? Can't gain 5. The most you can gain or lose is 3. So aluminum is going to lose 3. And when it does, it has now lost 3 negative electrons. So now it has 3 more positive protons than it does negative electrons. So it's more positive than it is negative, and its charge is +3. One that might be a little confusing to people is neon. Neon is what's called a noble gas. Neon is in group 8A. Noble gases already have 8 valence electrons, which is really important. So I'm gonna draw the dot diagram for neon. It's got 1, 2, 3, 4, 5, 6, 7, 8. So it already has 8. It's already satisfied the octet rule. It's happy. It doesn't need to do anything. So it's not going to gain or lose anything, and its charge will remain neutral, or a charge of 0. So that is how we do this.